There are two major systems within a primate that consume a lot of energy. First is the brain, and the second one is the gut system. And there's a tension between these two high calorie organs within our bodies that makes the adaptation of primates unique and interesting. So we basically have two strategies. One is to have a large brain, and that creates a lot of expectation on getting calories. And a primate will use this large brain to find the high value food items such as fruit within the rainforest environment. Yep, so it has a large brain which it needs to find the fruit and remember and how to extract it and where it is within a forest. But the flip side to it, it has to support a large brain with those high calories. The second strategy, which is equally as good, is to say, well, instead of looking for these high packets of high calorie items such as fruit, we'll just eat the vegetation, the browse and leaf around us. And we'll invest that energy into the gut. And so you have a long hindgut, you ferment the vegetation, but then you don't have the ability to produce a large brain, but you don't need it to find vegetation. It's very simple. And so you either have large brain fruit eaters, or you have small brained leaf and browse eaters with the guts and the hind guts. And there's tension between these two strategies. So for example, in the monkey world in the rainforest, you have your macaques, which are very smart fruit-eating primate, and then you have the not so bright leaf-eating monkeys such as the langurs, who use their large intestines, that foregut fermentation, to eat a lot of browse material. In the great ape world, we have a similar kind of diversity, where you have the gorilla, which is kind of like the not so bright great ape. In fact, many of the fruit-eating primates, the monkeys, the smaller primates in the family tree, are actually smarter than gorillas. This is because they've gone for the strategy, let's just eat the browse and leaves around. We have these big guts that we put the energy into, and we don't need or can support a large brain with this strategy. On the opposite side is the Sumatran orangutan, highly intelligent. And these beautiful Sumatran orangutans rely on high concentrations of high calorie food items within the rainforest to survive, and very little on the hindgut fermentation of leaf matter. Now, the important thing is that we actually have 3 species of orangutans, not just a generic orangutan. And if we look at 2 types of orangutans at the opposite ends of the range within the Indonesian archipelago, you have the Sumatran orangutan, which lives in the rich volcanic soil, highly productive soil of Sumatra. They're highly intelligent. They have an interbirth interval of 9 years, invest a lot by culture transmission from generation to generation. Yep. But they can't survive in very degraded environments. Because of this adaptation, they need that rich food source in order to survive with that particular adaptation. On the opposite end of the archipelago, you have the Bornean orangutan subspecies Moro, Pongo pygmaeus morio, and they are much more robust, which means big, like a gorilla, than the more gracile, slender Sumatran orangutan. They have only an interbirth interval of 4 years. They're not so bright. They have longer hindguts, means they're basically eating more bark and leaves than the Sumatran orangutan. And these Pongo pygmaeus morio seem to be able to survive in very degraded environments because they're more a leaf eater relative to the Sumatran orangutan, which is an intelligent fruit eater. Now this is extremely important because they're all called orangutans. So we are at risk of generalizing that we see what a Pongo pygmaeus moro can do to survive, especially, let's say, in degraded environments. But that may not necessarily apply to the Sumatran orangutan, which is a very different species. So, and this is obviously very useful to understand these concepts and this dynamic, this tension between the emphasis on the gut or the brain in order to try to affect meaningful conservation actions.